I want to show you some of the equipment you'll be using in the mass volume measurements lab. This here is a triple beam balance. Now I'm going to zoom in here on the beams, and we've got here the hundreds, we've got tens, and we've got units down here. So I want to show you what the smallest graduation is on the triple beam balance. So this is 1 and this is 2, and in between each of those you've got 10 lines. So each of those lines is worth 0.1. This is a 100 ml graduated cylinder. I'm going to zoom in here so you can see the graduations. So you're looking down here between the 60 and the 70, and what you'll be able to observe there is that if you count the lines between 60 and 70, there are 10 lines. So each of these lines is worth 1 milliliter. This is a 50 ml graduated cylinder. I'm going to zoom in here so you can see the graduations. So if you look here between say 40 and 45, you can see that there are 5 lines. So that means that each of those lines is worth 1 milliliter. This is a 10 ml graduated cylinder. Zoom in here, show you the graduations. And if you look, for example, between the 9 and the 10, you'll see there are 5 lines. That means that each of those is going to be worth 0.2. That's 1 mil divided by 5.2 for each of those lines. So this is a ruler. The large numbers here are in centimeters. I know it does say millimeters there, mm, but that's the smallest graduation. So if you count the number of graduations between say 0 and 1, you'll see there's 10, which means each of those lines is going to be worth 0.1 of a centimeter. So I want to tell you how to get the accuracy from a triple beam balance. As I showed you earlier, the graduations on the balance, each of these lines is worth 0.1. So what that means is, if we want the accuracy, each line is worth 0.1. To get the accuracy, we divide that line by 2 so we can see what it is in between the line. If we divide 0.1 by 2, we get 0.05, which tells me that anything I measure with this triple beam balance is going to be to 2 decimal places. So I've got some examples over here. If I've got this measurement here and it lies in between this graduation and this graduation, that's 5 and that's 6. So this would be 5, 0.1, 0.2, 0.3, 0.4, 0.5. That's 5.6. In between here would be 5.55. That's a measurement of 0.05 grams on the accuracy there. So that's to 2 decimal places. If it happens to be on the line, like right here, then this would be 1, 2, 3, 4, 5, 6, 7, 8. That's 0.8 there. But since it's on the line, it's going to be 0.80 because we have to measure this to 2 decimal places. Just because it's on the line doesn't mean that we penalize it just for being on the line by removing the 0. This needs to be measured to 2 decimal places, so it's 5.80. Any measurement we make using the triple beam balance will always end in a 0 or a 5. A 0 if it's on the line, a 5 if it's in between 2 graduations. So what we're looking at here is a 100 ml or a 50 ml graduated cylinder. I showed you what the 100 looked like and the 50, and we saw that each of those graduations, the small graduations, was worth 1 milliliter. So what that means is, if we want the accuracy, we take the 1 and we divide it by 2 and we get 0.5. So each of these can be measured to 1 decimal place. Now if it's on the line, like we've got here with this example, and here I'm taking account of the meniscus, which is the U shape that the liquid forms, we always measure from the bottom of the meniscus. And what I can do is I can count from here, that's 40, that's 41, that's 42. So this would be 42.0 if it's on the line. Up here, the meniscus lies between here and here. This is the 6th and this is the 7th graduation after 40. So it'd be between 46 and 47. So that would be 46.5 in there. And again, we don't penalize it just because it's on the line by taking off the 0 and calling it 42. Because this can be measured to 0.5, this can be measured to 0.0. This is a 10 mil graduated cylinder, and as I showed you earlier when looking at it, we've got 7 and 8, and in between we have 5 lines. So we go 7.2, 7.4, 7.6, 7.8 and 8. So each of those is worth 0.2. To get the accuracy, each line is worth 0.2. We divide that by 2. The accuracy is going to be 0.1. So I've got 2 examples here, one where it lies in between the lines and one where it lies on the line. Now since each of these can be measured to the 0.1, then anything in between the lines, this would be 7.1, so it's going to be an odd number. And if it's on the line, it's going to be even, so that'd be 7.4. So it goes like this, it goes 7, 7.2, 7.4. Halfway in between would be 7.1. On the line would be 7.4. So when I showed you the ruler earlier, what we noticed was that each of these lines here is worth 0.1. If we want the accuracy, then we take 0.1 divided by 2, which gives us 0.05. That means that everything here measured on the ruler needs to be done to 2 decimal places. So if I've got a measurement that's between these 2 lines here, for example, this would be between 1.0 and 1.1, so this would be 1.05 centimeters. This one is exactly on the line. Again, we don't penalize it by taking off the 0. It has to be measured to 2 decimal places, so that'd be 1.90 there if it's directly on the line. So this is a triple beam balance, and as you can see there are 3 beams. We have hundreds, we have tens, and we have units. And you can see the numbers on here as well. So these are 100 numbers, these are 10 numbers, and these are unit numbers down here. So I'm going to show you how to calibrate the balance first. To do that, move the sliders here to the very end. Make sure they're in that last notch. This one as well. And then what you want to try and do is arrange it so that this line is exactly on the 0. So I'm going to twist this knob here that's underneath the pan, and hopefully that will allow me to get to that point. So it's righty-tighty, lefty-loosey. Right will make it heavier, so push it down, and left will move it up a bit. So that's fine now. Now what I'm going to do is I'm going to weigh this beaker. So what we do is we move the sliders along until we see the slider go down, until we see the balance go down. See, now we know it's between 200 and 300. The important thing though is to make sure that you keep these sliders in the notch. So that's at the 300 notch there. I move this back to 200. I don't move it back to a point in between 200 and 300. The measurement is not going to be valid then. So then what you would do is move the tens to a point. Okay. Move it here to back to the 10, and then I can move the bottom one. And it's going to be fairly close to the 10 here. And then I move it to the point where that will line up and balance. So I'm looking at this now, and I'm going to zoom in on the sliders here. so we can get a better view of the measurement. So now we can see where the hundreds and the tens and the units are. So this would be 200, and that's 210 there. And over here, this would be 9. So 219 is what we've got here. And then we can look at the graduations here. This looks to be on the in between, actually, the 8th and 9th graduation. So I would measure this as being 219.85. Now, as I showed you earlier with the accuracy, if it did happen to be on the line, and I'll go ahead and I'll put it on the line, then that would be 219.80. That would be the measurement I'd use for that. I wanted to show you one more example of a measurement, something that sometimes people will get mixed up with. So over here, this is on the 10. I know you can't see it because it's behind the hundreds block, but the 100 is on the 0. So 10s here is on the 10. Now this one here is between 0 and 1, and you'll notice it's on the 0.8. So this would be 10.80, not 108.0. So that's something you need to be a little bit careful of when you've got a measurement between 0 and 1. Just realize that the unit is 0, and then you're getting into the decimal points here, so that would be 0.8. Now if this was just a little bit over, say we put it here, that would be between the 6th and the 7th graduation, then that would be 10.65. These are burettes, and burettes are used to dispense liquids. So I want to show you, just sort of zoom in on the bottom here, and you can see that we've got the stopcocks here, and those are used to release the liquid and then of course to stop it from coming out. What we've got here are two burettes, and they're kind of mimicking what we would do if we were using one single burette. So let me show you exactly what I'm talking about here. I will zoom out and I'll zoom in on the measurements here for the liquids. Now you can see the measurements here. This is one on the left, and you can see that the level is about here, and the one on the right, the level is about down here. The way the burette works is that if you start at this volume and then you release a certain amount of liquid, say down to this volume down here, then the amount of liquid dispensed would be the difference between the two. When you're looking at a burette, you're actually not measuring liquid, you're actually measuring empty space. So when you look closely at the graduations, I'm going to zoom in here on the graduations for this one so you can see them. Alright, so I've zoomed in now on one of these measurements, so you can see where the level of the water is. If you look closely, you'll see that it's shaped like a U, and that's the meniscus. And what we're going to do here is measure to the bottom of the meniscus here. So when you're measuring with a burette, you've got to be a little bit careful. First of all, you've got to take note of what number is where. So there's the 9 and there's the 10. So I know, for example, that this measurement is somewhere between 9 and 10. The other thing I need to worry about is what the value of each of these graduations is. There's 10 graduations between the 9 and the 10. I'm going to leave it to you to determine what each of those graduations is worth, and then how to figure out how many decimal places to make this measurement to. So this is a thermometer, and I'm going to zoom in here on the measurement. And you can see the measurement is going to be from where the red line ends, and you can see what the graduations would be if you realize that this is 20 and that's 30 and there's 10 graduations in between. You should be able to figure out what each graduation is worth, and then from there you should be able to figure out the accuracy and how many decimal places you should make this measurement to on the thermometer. I'm showing you here how to measure a block. We've got the 0 centimeters here is directly on the end, and then we can measure off by looking at the other end of the block. So I want to show you how to make a measurement on a 100 ml graduated cylinder. So you can see this one is filled up to a certain volume, so I'm going to go ahead and zoom in on that volume there. Now you can see at the bottom that you've got 70, and then at the top you've got 80, so the measurement is somewhere in between there. We said earlier that each of those lines there was worth 1 milliliter, and that will enable us to determine how many decimal places to make our measurement to. When measuring though, be certain that you look at the bottom of the meniscus. In a 100 ml graduated cylinder, the meniscus is not as apparent as it is in a skinnier graduated cylinder. But if you look closely here at the measurement, you'll see it's just above the 1 and probably just below the 2. So we're looking at a measurement of somewhere in between 71 and 72. So it'd be probably 71.5. Here we're making a measurement with a 10 ml graduated cylinder. I'm going to zoom in on the measurement. We had said earlier that when we look at the 10 ml graduated cylinder, between the 8 and the 9 for example, you're going to see 5 lines, which means each of those is going to be worth 0.2. So you can see where the meniscus is, and again we're going to measure at the bottom of the meniscus, and we're looking for the bottom of that U shape that you see there specifically for the water level. I'm hoping you can see that. That bottom of the U there looks like it's between the 3rd and 4th line. If each of those is worth 0.2, that means it's somewhere in between 8.6 and 8.8. So I would put that measurement as being 8.7. Measuring the volume of a test tube is fairly easy. What I've done here is I've taken a graduated cylinder and I've filled it to between 90 and 100 mils. What I'm going to do now is fill this test tube to the brim. And the difference now between where I started and where I finished will be the volume of this test tube. One way that I could calculate the number of drops in a milliliter would be to do as follows. I've got here a small test tube, and what I'm going to do is add 4 to 5 milliliters pre-measured here into this test tube. Now of course I know exactly how much I've measured because I've measured this, taken this volume here. Then what I can do is I can use this China marker here to put a red mark at the level of the liquid. Then what I can do is I can pour this liquid out. Then I can use a pipette here to measure how many drops it will take in order to get to this red line. By drop I just mean a little drop at the end like this. 1, 2, 3, 4, 5. Just counting the drops until we get up to this red line here.